Okay, welcome back. We're talking about the fourth normal form violation. So this one is a bit odd. What it basically is all about is I can't have a scenario where I have one row of information that really points to multiple rows of information. I know it sounds a little weird. Anyway, this is called the multi-value dependency. It's not the same as the multi-column problem. And so an example is an employee table that has skills and languages. Okay? Employee could have more than one skill and more than one language, but there's no implied relationship between the two. Let me explain what this means. Okay, so here we go. Have an employee ID, a skill, and a language. So employee number 1001 speaks English and he's a plumber. He also speaks Spanish and he's an electrician. So do you see a problem here? What if I was to write a query that said, I need a Spanish-speaking plumber? Would I find a Spanish-speaking plumber? I would not, because I asked for where skill is equal to plumbing and language is equal to Spanish. See how that query works on a single line? And my data is spread out over multiple lines, so I cannot find the information I need. This is bad. Okay, now you might look at this and go, well, wait a minute, you told me the one and only one rule, like an employee ID, give an employee ID, I should have one and only one skill, and you go, no, so it's obviously a normal form violation number one. No. The first normal form violation requires all parts of the primary key to be used as the identifier, okay? Well, I don't even have anything in here that's not a key. So the first normal form rule, although it kind of sort of looks like it, does not apply here because I don't have any other columns that are not part of the key. All right, let's look at another example. And the way you solve this is if I had another skill, so employee 1001 is now, I don't know, a carpenter. How many rows of information would I have to add to this table to make that work? I would have to have carpenter English and carpenter Spanish in order to make this thing work. So inserting one row, one piece of information requires me to insert two rows of data. Okay, that's a fourth normal form problem. Fourth normal form is all about I add one piece of information, but I can't do it. I have to add two rows. Okay, so here's another example. Here's Owl's Pizza and pizza variety and delivery area. So far so good, right? A restaurant determined multiple varieties. A single restaurant can have multiple varieties and multiple delivery areas, right? Okay. So far so good. This is not a first normal form violation because everything is a primary key. But the problem is they're not related. So if I was to add a new delivery area to Owl's Pizza, I want to go to some other Centerville. I would have to add a Centerville for thick crust and a Centerville for stuffed crust. So adding one piece of information requires me to add two rows of data. That is a problem. Okay. So that is that part in a nutshell. Now I've got one more thing to show you, and then we'll move on. Okay, so here we go. Here's just a review of the things one more time. All right, so first normal form says everything must be related to the key. That's first normal form. And it's functional dependency that does that. And how do you fix the problem? Although right now we're not talking about fixing it, but I would break a table up into two pieces. So here's an example. I have an employee, and I have an employee ID and a first name and a last name and a pay rate and quantity on hand. Like, what? Employees don't have quantities on hand. So clearly that's the quantity on hand is not related to the employee ID. Cool. Let's go to second normal form. Second normal form always has a compound primary key. And in fact, if you don't have a compound key, you can just skip this step, move on. So primary key. So here we go. A part number, a warehouse, a quantity, and the unit price. Now those are all legit. But the unit price doesn't change on the warehouse. The unit price is only related to the part number, not the whole key. So the whole key is part number and warehouse. However, parts of it don't belong. So the unit price isn't related to all parts of the key. All right, third normal form. Everything should be related to just the key. No jumping around. Okay. So in this particular case, I have an employee and a department supervisor. Right off the bat, there's nothing wrong with that. Given an employee ID, I should be able to tell the department and the department supervisor. However, isn't it fairly obvious that it would be better for the department to determine the department supervisor? So there's a little leaping going on here, a little daisy chaining where this thing determines that thing, but that thing determines something else. And so that's a third normal form. Okay, BCNF is the same thing as 3. The only difference is it's still a hop. You know, for example, the student determines the account, but the account determines the email, so it's still a hop. The only difference is that indeterminate thing is a candidate key. So one more time, once you detect the hop, the choice is between 3 and BCNF. Okay? All you have to do to make the determination, but after you've made the determination there is a hop, is it a candidate key or not? Okay, that's the only real difference. So the solution is the same. You still have to fix it. Fourth normal form is, okay, I've got an employee ID, a skill, and a language. So I put down plumbing, English, electrician, Spanish. Does that mean he can only do Spanish electrician? No, there's no relation. There's no inferred relationship between the skills and the languages. Therefore, it has to come out. Okay, that is it in a nutshell. I hope this was somehow helpful. And I'll see you guys in some future video, perhaps.